You're being recorded. Careful what you say.
It's just Kate listening.
Man, class is great without Kate here.
I hate Kate. This is gonna be so funny. Listen to it.
I mean, you just said it was funny, so it kind of ruined it.
So why did you make a voodoo doll of Kate and torture it? Maz, we shouldn't set it on fire. It's not true.
Can you send this to admin?
CC Bertha.
How crazy you are?
I have to get here early on Monday.
I am not crazy. You're the one that throws markers at teachers and stuff.
You just threw a marker at me. Mr.
I don't know what
Brown.
you're talking about.
See, you didn't even get that on camera or video. Or
What?
whatever.
Of you throwing a marker at me?
When you
no,
threw a
I
marker.
didn't.
Okay.
Mehak, I've seen you throw markers at other teachers too.
Yep.
What is this?
There's a trend.
Don't think so.
Okay.
Okay. Okay. So
Do it this
I
way.
was gonna grab my copy of the problem.
Can we just do
You
like
can't hold
two
it down.
groups of the problems,
No.
please?
There's one.
Why?
Why do
I like
groups?
it when he does it up there.
Because it's easier and faster.
I don't understand any of it.
Can we just?
I'll just glance at my house.
Wait, why is
That's
this
so
out?
funny. I'm smart too.
Yeah, why is that so
No
fun?
one said. I don't know.
Yes.
So
No one
let's
said
talk
anything.
for a second about the drag force. Okay, so this drag force, sometimes it's best modeled by this velocity to the power of 1. Sometimes it's best modeled by the model of velocity squared. You actually have to go collect data and see which one linearizes better. I often find when dropping coffee filters that CV works better than CV squared. It tends to depend on the shape. The letter C in front is to allow for the shape of the object and the density of the air and the humidity of the air. All those things are packed into the C because they all affect the nature of how the object is being dragged by the air. But sometimes the coefficient here should be a 1 that we're raising the power of velocity to. Sometimes it should be a squared. And there's no way to really know sometimes unless you get out there and you start gathering data. Friction is this way also. Friction's an empirical thing, and the only way you figure out what friction is you do services, you don't predict it, you go find it, you calculate it. And then once you have all the friction stuff, then you can try and mathematically model what it is. Again, all this is for laminar flow, not turbulent flow, like turbulence in an airplane, because you never know when you're going to hit the next bump in turbulence. It's very unpredictable and nonlinear. And so we don't use this kind of math to solve that sort of thing. So they do give you the masses there, and they give you the velocities, and they ask you to find velocity squared. They ask you to graph. And they even put on the graph what they want on the x-axis for you. Okay, they've already got the kilograms here. And you, all you have to do is create the velocity square graph over here. Do watch your units that you would want meters squared per second squared on the axis there. And you're gonna get some dots, right? And you're gonna linearize this thing and get a best fit line going through it. And when you do a force diagram of your filters, you're gonna have 2 forces that are occurring, FG and FD. They will be congruent at terminal velocity. Okay, so when you are looking at that moment in time, when our velocity first becomes constant, these 2 forces are going to be equal 0 because there's no acceleration at that moment. And so we'll be able to plug in CV squared minus mg equals the 0 and calculate that terminal velocity if it asks us to. Which of course that'll be changing for different masses, okay? They want to use the graph to calculate C. So let's take a look at what we graphed. Here we graphed V squared versus M. So if we look at that, V squared over M is going to be equal to G over C. If that makes sense.
Why would you do that? Why wouldn't you just get V alone?
Well, this is what I graphed on my 2 axes. Here's VT squared. here's the terminal velocity squared versus the m.
So the slope is G over C.
And so I believe, if we're not messing it up, our slope is g over c. Sound good? All right, and so then what we can do is we can use the slope of this to solve for c. Because whatever number you get for the slope, it'll be equal to 9.8 divided by c, or 10 divided by c. 10 is simpler to use. So c would be equal to 10 or 9.8 divided by the slope of your graph. Please make sure on these labs, we mentioned this the other day, we did the gravity problem, don't use your data points. Or avoid using your data points. Instead, choose 2 other points on your best fit line that are not data points. Even if your data points, usually with a scatter plot, the best fit line is going through the data. You got about half the dots above, half the dots below. And so you're not necessarily hitting a lot of data points anyway, but choose 2 points there and mark them on your graph if you want to do a rise over run hand calculation, like y2 minus y1 divided by x2 minus x1 to find slope. Also, I really think the easiest way, and much more error-free, is to type the data table into your calculator and just quickly do a linear fit, okay? And I would write down on the paper, use calculator to find slope, and then write the slope down, okay? And they're completely accustomed to students doing that, okay? But you do have to note, I would recommend writing down that you used a calculator, okay? So you find C, what do we find for C numerically? What did you guys find?
I got
0.0475.
I got 0.046.
I got 0.045.
Okay. All these are fine, and you're getting slightly different answers because of what?
Rounding.
What data
Picking the
points you
points.
use?
Yeah, your best fit line is not the same, okay, if you did it by hand. Your best fit line is not quite in the same place if you found points off of it and you went by hand. If you did it in a calculator, your slopes should be about the same, and they are. There could be a little bit of rounding difference, certainly. And I'm struggling a little bit over what the units would be here. So you'd have meters per second squared for the G,
kg over n.
and you'd end up with, was kg over m? Okay, and then here for the velocity squared, I'd have meter squared over second squared over kg. Yeah, I agree. Kg divided by meters. That equal doesn't make a lot of sense because I lost the number, but you get it. So that's going to be the first part of the problem there. Let's take a look at the next part of the problem after the graph. And I'd ask you to sketch the velocity versus time of the filters from the time that they are released.
I forgot to do that. Did I do anything else?
Indicate the time capital T and this terminal speed VT on the graph. I'm having trouble figuring out what the capital T is, sorry.
Capital T is just any time. Like Loki, like it doesn't matter.
Okay.
It says sketch where released up to the time T.
Basically when it hits the ground.
It's when it hits, yeah.
Is it when it hits the ground?
No, it's when it hits terminal speed.
Terminal speed.
Yeah, that's why
That's
it's
what my
V-
question.
V capital T.
Okay, I guess.
So it's like T and
No, but it
So
doesn't-
capital T is the time it reaches terminal
Yeah.
speed.
No,
At
that's
what
not what it
time?
says though.
I think.
It says that they
Sketch the
fall in the
approximate graph
distance
of
y.
the speed versus time and the filters are released up to the time T equals capital T that the filters have fallen a distance y.
Because I ask about y. But, so like it's not really relevant to I, but it's relevant to I. Because then I is like how could you find use the graph? Not that graph. Like we've moved on.
Right, I know.
How can you use that graph to find y? And
Got
so
it.
you have to have capital T marked to find
Somewhere.
y.
Yeah. Okay. So, so here's the velocity changing with time, and
Like this.
I'm going to first identify my point of terminal velocity, which I decided, if looking at this, it looks like the terminal velocity would be equal to the square root of mg over c. So I'm going to note that over here on my axis before I even draw anything.
Do you have to write the square root of mg or c? Or
You-
can you just write dt?
I think you're allowed to write VT. Yeah.
That's so extra.
And so I'm going to put an asymptote, or that I'm going to approach, a dotted line there, that my asymptote will approach, and then I'm going to draw something like this.
You can put T, capital T, anywhere.
Yeah, anywhere. So then my VT has been marked. I'll just mark a capital T right here. It doesn't really matter where it is. I agree with you. And they do ask you, how would you find the distance y fallen in this much time?
Integral.
Right, and so this would be an integral, which would give you the what of the graph?
The area under
Yeah, it
the
would give you the
curve.
area under this curve. So this area right here is your displacement, because our graph is of velocity versus time. Okay.
Would you need to talk about how you could estimate area from the physical graph itself, or could you just say take an integral?
Just say take the integral.
What's your answer?
Because it's talking about approximating the distance y, I would just say find the area under the curve, up to from 0 time up to the time capital T, and that would be the displacement. I don't think you would need to, you might say integrate, I don't think you need to talk about your approximation method per se, is that what you're asking?
Yeah, would they accept just integrate? Would you need to talk about how you could approximate from the graph itself in front of you?
Yeah, well, good question. So I will come over to my computer and bounce out of the little video screen for a second and glance at their rubric and double check what they accepted here. My guess is they're just going to be looking for that the integral under the curve is the area, and that is the displacement. And I think if you mentioned that you're looking for the area, and you mentioned the area is the displacement,
I just want to know.
I think that you would be okay. What year was this? 2013?
10.
10? Thanks.
I think I did the last D wrong. It was, yeah. I got 1/2 mvt squared minus mgy, but I feel like that's 2.
That's what I got.
You got what?
That's correct.
MVT squared.
I checked my answers.
I don't know why they would ask that question.
If you don't use integral thing, don't think that's right.
Why did
Yeah, I
the
don't think
kinetic
it's supposed to
energy
be integral.
cancel?
I was thinking about finding the initial position at
Because
MGH
the
and then doing
final-
1/2 MV
Yeah, I
squared
did
minus
that,
MV. But I don't know how that would work out.
I feel like you're supposed to do the.
Okay, so to answer your question, Soham, they said for a verbal statement that clearly indicates that the distance y is the area under the curve between times t equals 0 and t equals capital T, 1 point. That's it. You could make an equivalent statement saying the area under the curve beginning at 0 and ending at capital T equals
So
This would belong.
displacement, or you could have given the integral method. And you could have actually written out that y equals the integral of v with respect to t with limits of capital T and 0. So some people, they accept mathematical expressions or written expressions. Okay. All right. Last part of the question here is to determine an expression for the amount of mechanical energy dissipated due to air resistance.
2 Newton.
And so here, all we're going to look for is the difference between there's going to be a difference between the kinetic energy it does have and the potential energy it started with, right? So if we start with our coffee filter up at this height, and the height is y, right? We have a certain gravitational potential energy relative to our position that we're going to call h equals 0. And our initial gravitational potential energy is just mgy. But not all that's going to be converted into 1/2 mv squared. Some will be dissipated as heat. As the coffee filter is moving down, it's hitting the air molecules, knocking the air molecules out of the way, and making them all move faster. And that's the heat that's being generated. The average kinetic energy of the air molecules increasing is the heat. So you would just look at the change in energy here. Okay, so mgy minus 1/2 m.
That's not the way around. If you have
Oh,
down,
final minus initial.
well, if you have
What's the exact wording on the?
It's just
I had,
Delta E, so
I
F
had
minus
down
I.
equals negative. I had mgy being there. Yeah, then switched.
Why'd I add them?
Yeah, it does say dissipated. They may be looking for a negative answer. I will double check, but I agree. Final minus initial is good to go with.
What?
No, minus.
No, you want to subtract. You want to find the difference between
Yeah,
these two.
'cause when you start and end.
Yeah. So this right here would be the energy final. This would be the energy at the bottom. The mechanical energy. It would have no MGH anymore because we're at H equals 0 at the bottom. And this would be our mechanical energy initial. Sorry if I'm saying right in front of you, Gabe. Because we have no kinetic energy in the beginning. So, because we dropped them from rest.
Mm-hmm.
And so it's the difference in these two
Is
energies.
there no potential?
That is the.
In the beginning, there is potential. It's
I mean,
all.
in the final.
No, because once you follow distance y, that's where I set my reference point of h equals 0. So you'd have mg 0 would be the mgh. Okay, so we'd have potential energy or kinetic energy minus that potential energy. These would be equal if there was no air resistance. You get 0, but because of air resistance, you will not get 0.
It is.
Without you, Kate, Meg's on her best
Oh my god, I forgot we were recording. I was so confused for a second.
I thought he was talking to me. I was just like, okay.
Can we all say hi?
I miss you.
Look at her hat.
Can I say hi? Hi. Maybe that was like texting her like 2 seconds ago.
We're all here.
Oh.
Okay.
Except you.
You're great.
You're
All right.
great. She's in Boston. She doesn't
what's that?
even need to be in Boston.
She doesn't need to be in Boston. Why not?
Can she see you now?
Sure. You mean live?
Yeah, no, like,
The camera's fine, thank you.
okay. Because we all know she's not going there.
Going where?
I'm kidding. If you love it, you should go there.
She says she really likes it.
Where?
Which school is she?
Boston College.
Oh, Jaya goes there.
No, she goes to
BU.
BU.
Oh. So I read somewhere that if you drive with your like windows open, it like gives more air resistance.
Yes.
It does.
And they like use a lot more gas.
That's what I was
saw
gonna
that in
say.
Mercedes.
It does?
Oh my gosh! I saw that a couple of days ago.
It does. And part of that's because you're not getting smooth laminar flow of air over your car.
Mehek's got a.
And
her
so the
windows.
air that is kind of like beating in and out of the windows, that's blowing in and out of the windows, is causing lots of little vortices of air inside your car. You're getting all this weird turbulent flow of air around the car because of the flow of air in and out of the windows. And you want the smooth laminar flow of air just moving right over your car in order to, that's much better, Kate. In order to get the least air resistance possible, okay? That's what planes try and do with their streamlined shape. That's what our coffee filters try and do with their kind of self-correcting shape as they
That's
fall.
not why they're shaped like this.
No, that's not why they're shaped. That's what they do with the shape. Yeah.
Oh, but
I
it's
agree.
like
they're
you
shaped
said
that
that's.
way to catch coffee.
I think you said like that's.
That's their inborn purpose.
Yeah, that's
Yeah,
what
that's
it
why
sounds
God
like.
made them that way.
I have
When they were
destiny.
born. When I picked them off the filter tree. Okay.
They self-corrected.
Let's do the next problem.
Yeah.
That problem is really straightforward, right?
This one was.
And I want to emphasize also
Both of
that
these
I
are
like that
really
coffee filter problem because if you got blown away in the first part of the problem, you can still do the second part of the problem.
Yeah.
They're almost disconnected from each other, and that they're not reliant, and you don't have to get one part where you get the whole thing right.
Yeah.
The next problem you had there had some graphs on it, and that was probably the main point, was just the graphs.
Okay, that's like.
So you have a couple force diagrams, and then they do want you to find terminal velocity, and they want you to draw the three graphs. And is that it?
Yes.
Yeah, that's about it. I don't think I did.
You could put
Yeah, that's pretty simple.
1975,
We know
they
this in
had
about
it
1 minute.
made.
You did yours on.
So when it first starts falling and it hasn't been going
The
anywhere
height
yet,
is 0.
right? We're just gonna have gravity acting on it.
Mine look like his.
Right, because there's a velocity of 0 in the beginning. After it's been falling, I'm going to add in one in the middle here. So after it's been falling for a short time, you would have a force of drag. How do they call it force drag in this? R.
Okay. Yeah.
So you have that resistive force that would be longer.
I was wondering, would they ever like label a force retarding force on today's exam? I'm like actually curious, because I feel like the retard, like that like base word has like a lot different
They
like
call it F-drag
connotation.
most of the time today. Most books do too.
Yeah.
I don't think the word. I'm not sure if it's because the word retard and retarding would be politically incorrect,
Mhm.
or if it's because they've, for other reasons, moved away from that word. I think the word drag is much more obvious what they mean. Maybe it's because the English language is shifting. But it is. Did we actually mark these congruent?
I
On
didn't,
yours?
but that makes sense.
Oh,
Yeah, I would have.
Should.
Yeah,
But
I
I didn't
did.
them the
Should.
same size.
yeah. You should mark them
I did too.
congruent.
And then for that, I said FG is greater than FR.
Mine is just obviously bigger.
Be in FR if it's right after.
There should not be FR in the first one, I don't believe.
Like little.
Well, it's like just after it's released.
No, if it says, what are the words there, Moz? When are you doing it?
Just after it's released.
There's no.
There's no FR. Yeah, so this is single I, all the way on the left. I drew the middle one to show what's happening over time, and then we eventually get to this point here.
T equals 0, 0.
We've already solved for,
Okay.
is it KV, is the retarding force in this one?
Yeah.
Yeah.
FR equals
We
negative
did this in class.
Okay, and I did, yeah, I'm not gonna spend a lot of time on it. And so, the terminal velocity would be mg over k, we got that. And then they want you to draw graphs, okay? And we've done the graphs a little bit before. And did they tell you where to start your graphs? Did they give you an
I
initial
did
point?
it the opposite way.
Yeah, I think it's the
How so?
way.
Like I had the other, I had FG is positive. instead of negative.
They
In
had
this statement here?
Yeah.
Because you have one term positive, one term negative, they're equal and opposite. It doesn't really matter which one you call positive or negative here.
But when I graph it, I graphed it in the first quadrant instead of the fourth.
Got it. I'm not, that's what I was asking if it mattered. I'm not sure that's wrong.
Okay.
And so,
Everything
Yeah,
has
because
to
I
be
think that's what
consistent.
I did.
so they want to see how the acceleration changes as a function of time, the velocity changes as a function of time, or the position is a function of time. So, I put position up here first, but I'll switch and do acceleration the way they did. The acceleration obviously starts at 9.8, okay, and decreases to 0. And so if you chose to do positive, then yours looks like this.
They don't even
If you
do
chose to do a
positive.
negative, then you do it like this. And I would say the way they defined it, either one's okay. Okay? And then for velocity versus time, here I'd be a little more specific. We have a VT. I would actually mark it. If you ever can mark something on your axes, like you know what this value is, then I would do that. Okay?
I didn't put on the axes, but I wrote
I even wrote it.
at b equal to negative mg.
That's fine. And I'm not trying to say like you have to do it this way. I am just saying that I think that it is better. They really, when you're drawing a graph, all they're really going to care about is concavity. Is it concave up, concave down? This would be concave up because you would rapidly increase your speed in the beginning when you have lots of acceleration. As the acceleration gets less and less, you're increasing your speed by smaller
That's
and smaller
concave
amounts over
down.
time. Did I say concave up?
Mhm.
So sorry. This top graph here is concave down. Yes, the bottom one is concave up. But so this is concave down here
that
because we're
calculus
increasing by
steps.
smaller and smaller steps as we go, approaching that. So they care about concavity. They care about overall the shape of it. If you have is a positive or negative slope. Okay, this is a positive slope because we're picking up speed all the way with a positive A. Again, assuming we're in quadrant 1, not quadrant 4. And they care about things like intercepts, either x-intercepts or y-intercepts. So in this value, the asymptote is approaching that VT. So to note that, if you know that, it's never going to hurt you. And even if they don't explicitly ask for it, they sometimes put it in the grading rubric. And so I would recommend that you do it if you know it. Lastly, the position. If you want to start at a position of 0, I think that's probably most appropriate. And you're going to be moving slower first, then faster and faster, and then you kind of have a constant speed from there, right? So we have a curve that is not parabolic, but more some e to the x-ish thing, and then we're gonna have a straight line, yes?
If I started above 0 and then terminated the graph when it intersected the x-axis, is that okay?
If they don't give you, and this again, this problem is 1975, this is a long time ago. So they didn't give you a rule as to where you had to start. Today in our problems, they would often say start at x equals 0, time equals 0. They would give you something because they only want to have one right answer. And so they want to be able to look at the paper and in less than 1 second decide if you're getting 1, 2, or 3 points for that graph, right?
Because they're grading a lot more.
Yeah, you can. Yeah, they are grading a lot more, and they also it's also easier on students if they give you a little more guidance, and it's not wide open. Okay, there is one more problem I want to work with you.
So.
Maybe two. Actually, I'll give you one. While I'm looking for a piece of paper, I'm not finding it right away. So here's a quick little problem.
I don't know why.
So let's say I have a wiffle ball like this. Okay, so wiffle ball picks up a lot of air resistance, and I throw this wiffle ball as hard as I possibly can, straight up in the air.
Do it, please, please, please.
It would hit Victoria straight.
It doesn't even matter because there's already been Coke all over these.
But not on me.
Coke, like
Well, I
cocaine?
did-
But he's throwing it straight at the air. Straight up in the air.
Up in the air. Okay, just for you, Kate.
One of the pom-poms came out.
Look at the got stuck up there.
One of the pom-poms did come out.
Kate would have loved
Wait,
that.
did you actually
sorry.
like,
We miss you.
when you got the Coke?
That's no exaggeration. Our, I want to say 3 people were just taking them down, handing them down, and then another 4 or 5 people were just scrubbing and then handing them back and putting them back up again. We cleaned like 10, but you can still see the Coke. It's all on the lights right here. We didn't clean the inside of the lights. We didn't clean
Did you get
some of the ones further away.
Oh, I
There's
see
brown
it.
dots over here. All these brown dots over here are Coke. We cleaned the ones in the middle because they were all covered. We didn't get the ones in the far outer
She is
edges.
so dumb.
She's not so dumb.
Yes, she is. It's
Maybe a
Lauren.
little, Lauren.
Lauren's not gonna watch the video.
Who knows if she's gonna see it or not?
It becomes like
But don't worry. She felt silly enough at the time.
Did you hear what Lauren did yesterday?
No.
Okay, so she had A1 free, right?
Okay.
So she's
Oh,
sleeping
she's
and
such
she
a
told
silly
her
one.
mom. She
Oh,
told
yeah.
her mom.
She told us
She's
about
like,
it.
Yeah.
And she's like, okay, just like I'll like wake up to my alarm and come to school like for A2. She slept till 1:30 and came to school like in the middle like of their English class and just like she just like didn't go to A2. She didn't go to like 3/4 of A3. Like how dumb. Like she just didn't wake up to her
She made a
alarm.
mistake. What?
It's so funny.
She was subconscious.
Does no one find that
Wait.
funny? It was really funny.
Yeah,
Oh,
thanks.
I was like, what?
Okay.
Do you
Please-
know that
Sorry,
Please do me a
Stupid
favor, and I
so
want you to
hard.
rank.
We already need the story, man.
I want you to rank from greatest to least.
Are you playing Hangman?
Yes, we are.
I want you to rank the acceleration from greatest to least. Please don't call answers out. I want you to rank the acceleration. Again, I'm throwing a wiffle ball up, straight up, as hard as I can. Okay? Wiffle balls are going to reach terminal velocity at some point, as they do. Okay? And so I want you to rank the acceleration at these 5 points. If 2 points are equal, you may mark equal in between them. Okay? Think about it all by yourself for a minute. This is totally self-practice. And we
Got
will
one.
go over the
I
answers
can't
in a
find my
minute.
pencil.
Okay, please try.
Wait.
I dropped a bomb bomb. It's there.
Was that English you spoke?
Are you kidding? I said I dropped.
It sounded like mama. So it sounded like.
Thanks, Gabe. Gabe understood me from all the way over there.
Okay.
Gabe, the hoop is made of soft aluminum. It will not stand up to that. So I'm going to ask you to return it to its box. And let's not play with the hoop.
This one's made of plastic.
I'll email you the problem, Kate.
I thought you were talking to this Kate again.
I was like, what's going
Screenshot it
on?
now.
Yeah, screenshot, get the problem, and then I'll email you the PDF. Okay.
Oh my god, she's gonna be dying.
Wait, are we doing this problem or are we just working on the ranking
The
test?
heck said she hopes you die watching this
No,
video.
I meant it!
I just think it would have been cool if you died on Halloween.
Whoa.
If I died on Halloween.
No, that's an inside joke between me and Joe Cloud because he was absent on Halloween and.
Joe Cloud's not here. I just want to clarify for you, Musselman, in case you were wondering if he's here. And McGarity was like carrying on a normal or reasonable conversation.
That's actually
Nope.
hilarious.
Wait, greatest to least or least to greatest?
Greatest to least. Greatest acceleration to least acceleration. Again, if 2 points are tied, please feel free to make them as equal.
I know it's hard with air.
I just can't see the board,
Oh, good.
sir.
Air resistance.
Sir.
Why can't you see the
You
board?
know, I'm not doing that.
She better take screenshots.
Yeah.
That's in front of the
Screen
camera.
record.
Musically
on it. Let
Put
it
the
go.
screen on it.
Yeah, maybe I should not put this one on my OBS.
Wait, why can't you
Like
just send
somebody
it
walks
to her?
behind Kate while she's watching this video, and it's just you dancing.
Mine would be a funny moment indeed.
Oh my god, wait, I really need to give that video of you dancing to Mr. Dunn. I kind of promised him one.
Kate, can you help me understand why you promised Mr. Dunn a video of me dancing?
Have you seen that Six Flags ad where the old man dances? Well, Mr. Dunn played it in class before we went to Six Flags, and he was like, McGarity, I need you to get a video of Mr. Brown dancing to this song. So, I didn't do that, but
You
I
just
could
put the
have.
song
You
in.
should look it up. Victoria knows. It's pretty funny.
What's
The
the
song.
All right, you have 30 seconds to finish your ranking. So some of you have nothing written down on your paper.
I think I got it wrong.
I wrote it down.
Are you finished,
It's
McGarity?
not right.
Yeah, it doesn't. I don't know what I'm doing, but I wrote down a ranking.
Wait, do negatives affect?
Yeah, are we doing it by
Are we
magnitude
doing
or
it by-
like?
You can do it by magnitude. That's a great question. You can do it by magnitude. Yeah.
I'm not changing that.
So I don't care if we don't have to call up positive and down negative and rank from positive to negative. No. Do it by magnitude. Thank you. Excellent question.
What? Who put these pom poms in here?
Magnitude is never I mean, the direction.
Who is tapping the desk like that? I'm
Bouncing a
lose my mind.
To understand that would be to understand the problem song. I wouldn't necessarily take for granted that that's going
I'm
on.
gonna punch you.
That what's going
This doesn't bounce. Sorry.
Somehow the desktop got my computer got bumped. Okay, so please share your answers with those next to you.
Hi, Sohan.
There's like got like 15 minutes in the middle of this video. You can just like fast
I
forward,
think this
Kate.
is wrong
I
too.
mean, it's just.
But I was like,
That's interesting.
I'm gonna pause this for a minute while they all chat. Chat with yourself, and we'll get back to you.
I put the
Pretty big.
So A is the answer for the greatest acceleration. The heck, why?
Well, I get
I don't
Impress
wanna-
Musselman.
because
I don't want to say now. Because so the ball is being thrown upwards.
Yes.
And the air resistance, whatever it's called,
I got it. Can
Air
I do
resistance.
it?
That's what it's called. Go
that
ahead.
is going in the same direction
No,
as the way it's being thrown.
no.
Your head so just tell me what it is.
No, don't tell her what it is. It's okay.
Opposite direction.
No,
Gabe, you're the only one who voted for this that I haven't asked for other than Soham. And so I'll ask you then Soham.
So
I want to do it.
the ball has just been released from the person's hand, so
Yeah.
it has the highest velocity on its way up. So both the
Oh my God,
force
I
of
think
drag
it's
and the force of
Okay.
gravity are pulling it are
I've been
pointing
pointing
down, which causes it to have the greatest
Actually,
acceleration
fit.
downwards.
The shot they got.
Oh, it's
I have to
good.
poke them out.
It's going against 2 forces,
Okay.
which
Cool.
is why it's and it's
It's
also
okay, I
where
don't
it's
give
got
up
the highest
on
velocity.
No, I'm
All the
kidding.
way up.
It's not your fault. It's mine.
And then the head pointing is lowest because of the movement.
I think he knows.
It's much easier to see if you draw a force diagram.
So when it goes in opposite ways.
Here are the first three force diagrams. It's traveling faster on the way up at point A than it is at B. And so you have more drag down. The drag has to be down because it's going up and drag resists. So if it's going up, the drag goes down. Those are opposite directions. And so these two forces that are down add together to give you a larger net force downward for a larger acceleration. So it very, very quickly slows in the beginning. And then as it rises, it's slowing down, so the drag gets less and less. So that means the net force is less and less. With less net force, there's less acceleration. Less F, less A. Here at the top, what would the acceleration be? Just 9.8 meters per second squared toward the ground. That's it. Okay? So that's the acceleration. How about a point D? Why is D not equal to B? Because it's not.
Because the drag is opposite.
The drag flips directions. That's very correct. So here we still have the same FG. FG does not change in any of these, but now this F drag is going the other way.
That's what I meant.
Okay, so here at D, the F drag is going the other way, and so my net force is now getting less than its mass times gravity, acceleration to gravity. It's getting less than the weight. And so my acceleration is decreasing. By point E, maybe it's reached terminal velocity, maybe it hasn't. But regardless, it's going faster, right? And so as a result, it's going to have more drag than it did at point D. And maybe it's reached terminal velocity, and there's no acceleration by this point, okay? But clearly, that's how the accelerations rank. This was actually they expanded this into a free response problem several years ago on the AP test, okay? And there was a complete math component to it, a graphing component to it, which is pretty cool. So what I would like for you to do for me is I would like for you to graph the velocity versus time of this, where its initial velocity you can call VI, the initial velocity. Please consider upward is positive and downward is negative. And I want you to graph the velocity versus time for this, now that we've discussed its forces and acceleration. Okay? Upward is positive, downward is negative, and the initial velocity would be VI. Why did you take out all the purple?
I didn't.
Why did you take out a bunch of the...
I wanted to. I'll put them back.
Go ahead. I don't even really care. It's just a wiffle ball. I didn't put them in. I don't really care if they're taken out.
Who put them in?
I don't even know what year it was done. I want to say when I got here, there was a bowl of balls. It's like 2 feet across, a big, big bowl full of all different size balls. And that was one of them. But I keep it on my desk because if I want to throw a ball in my classroom, a wiffle ball is a safe one to throw.
So no one has ever tried to take these out before?
But you have a bowling ball.
Yeah, the bowling ball is for objects of large inertia, not something I would throw at a student.
What
I
would
can
you...
safely throw a wiffle ball at a student and not hurt anybody because it's a wiffle ball.
He threw a marker at a student today.
Oh, nonsense.
That was
The
Mehek.
heck threw it at me.
What are we doing? I'm so confused.
And that's because you're working on little purple pom-poms and you're not working on physics.
I understand the ranking.
So please graph for me the velocity versus time of the wiffle ball while it's in the air.
This is right.
Upward is positive, downward is negative. The initial velocity is VI.
Upwards is positive, downwards is
That's
negative.
what I said.
I incorrectly thought that it was first concave down for some reason. Because I thought the acceleration was negative.
I know that
see,
it
you
has
also
to
had
cross
it
the
pointing
x
in front of you.
You
axis.
said negatively, right?
Yeah, so it goes 2, and then it goes.
That's what I thought.
Oh, nice.
We'll see how it ends up, though. Last time I gave an answer, that wasn't right.
Hey, but what's it name?
Okay.
So it's just gotta decrease. I mean, it never stops decreasing. It just decreases.
Yeah.
The first thing I want to do is I want to add in where my VT is going to be. My terminal velocity is going to be there. It's something that's negative. I'm not sure what it is, but it's something that's negative. The next thing I want to do is I want to drop in my VI. My VI is thrown upward, so I'll mark VI right there. Okay? The next thing I want to do is I want to draw in my velocity.
It's kind of satisfying.
Taking these out.
Oh, okay,
We were
cool.
close.
It's all concave up, though it spends half of the distance it travels is up, half the distance it travels is down, half the time is not up, because it decelerates very, very quickly with two forces working against it up to the top. And as it comes down, the two forces work against each other. So man, the magnitude of that acceleration is much, much less. It's gonna take a long time to fall by comparison to rising. So I want to make sure that I cross the axis where the velocity is 0 to the left of center. In fact, if I was to measure the slope right here, the slope of my v versus t graph right there should be negative 9.8 meters per second squared. That's the slope of the graph right where I hit v equals 0. And that's what we stated up here. We said up here at the top at point C, where only gravity acts on it, it should have an acceleration of 9.8. So I always want to be accelerating all the way through here, but the acceleration approaches 0 as I approach terminal velocity. Okay? When they did this graph on a free response problem, it was a graph for 5 points.
Whoa.
Big points. Okay? There's a lot to get right. You had to mark the axes with the terminal or with the velocity they gave you. You had to mark the terminal velocity down here as an asymptote. You had to be concave up and the whole time. You had to cross the axis left of center. It had to asymptotically approach that asymptote.
Can you explain why it's concave up the whole time?
Sure, yeah. Concave up the whole time gives me what kind of slope to this graph?
Negative.
Negative. The acceleration at all times is negative. The
Okay.
acceleration is this way at all times. It gets less and less acceleration, right? And then here it's just 9.8, and then here it's actually less than 9.8, and then here A is 0. So the acceleration is downward at all times, Kate, and so
Yeah.
therefore it's got to have a concave up or negative slope at all times.
That makes sense.
Yeah.
Little middle schoolers singing this
Sorry, we all missed that. Okay, hey, I dropped the problem in front of you, a free response. Let's go ahead and work that free response. I'd like you to try and work it in groups. Okay, my computer says it's got like no battery left, so we're gonna cut this recording here in a minute, kiddo. But the problem is here working the board. Part A is over here, force diagram. Part B is over here, differential equation. Please note it must be dv to t to be a differential equation. Part C is here. If there is no acceleration, you quickly solve for v. Please make sure you have a subscript t on your terminal velocity. You can't just put v. It's got to have a subscript t. They're looking for that. They grade for that. If you just put v, that's any velocity. This is a definitive velocity. Part D is rather lengthy. You might want to just kind of freeze the screen there and look it over. It's a pretty long little derivation. Here in the middle, I kind of set up a u substitution. I wanted to make sure that the top of my integrand was the derivative of my bottom. So I did a little u thing here to make sure that got set up correctly. And part D continues over here. And then part E is just the graph. Okay, I'll let you look at that. I'm going to end the recording here. Have an absolutely beautiful day.
Bye, Kay. I love you.
Oh, they love you, Kate. At least
Bye, Kate.
they say they love you. I don't know. Okay, now you can say it.
Bye. Soham, say bye.
Oh my god.
Okay, bye.